This video is on electrolytic cells. So this is another type of electrochemical cell. A voltaic cell is when you have a spontaneous redox reaction that produces an electrical charge. So it's spontaneous. An electrolytic cell is different in that it uses an external source of voltage to bring about the redox reaction that would otherwise be non-spontaneous. So this needs some sort of power source to make the reaction happen. It enables neutral elements to be released from ionic compounds. So an important process in industry, it's used to manufacture many chemicals. They have to have the following components though. The source of the electric power is going to be some sort of battery or DC source. It has to undergo a chemical change. Usually you're going to have molten or aqueous solutions of ionic compounds. There have to be electrodes made of either graphite or metal. And they have to be connected to the power source. They must not touch each other. And then you have to connect your power supply to your electrodes. That made a right here to make that connection. You have to have your electrical wires. All right, so when comparing voltaic and electrolytic cells, the electrolytic are simpler in that you're going to have this, like if I go down here for a second in this diagram, your electrolytic cells are going to be in one container would be like your electrolyte. So like here's, let's say, your beaker, right, with your solution. You're going to have your electrodes, your power supply, right? That's the battery in this case. And you have to put the energy into it. Whereas a voltaic cell is more complex in that you have your two containers, right, with a barrier, and you've got your salt bridge, right, completing the circuit so that the electricity can flow. All right, so kind of similarities and differences. In both voltaic and electrolytic cells, oxidation occurs at the anode, reduction occurs at the cathode. So that's the same, right? Oxidation anode, reduction cathode. So you could think of it as oxidation and anode are both vowels, reduction and cathode are both consonants, or an ox red cat. An ox red cat. In both kinds of cells, electrons flow from anode to cathode, so they still go electrons from here to here. However, in voltaic cells, the electrons flow naturally. Because remember, this is spontaneous. And in electrolytic cells, the electrons are forced to flow. This is where the battery comes into play. So in a little chart, kind of differences. So voltaic cells are spontaneous that produce electricity. Electrolytic are non-spontaneous. In a voltaic cell, you're starting with chemical energy and you're turning it into electrical energy. So the chemical energy is from your reaction that happens on its own, which then produces the flow of electrons. That's what electricity is. In an electrolytic cell, it's the opposite. You have to use electric energy to make the chemical reaction happen. And the anode and cathode charges are opposite. So an anode is negative in a voltaic cell, cathode is positive, but they're the reverse in your electrolytic cell, where the anode is positive and the cathode is negative. So if I go back to these pictures, right, in our voltaic cell, we've got our anode right here is negative, right? Your electrons leave this. This is where oxidation happens, right? Your electrons leave. They go up through the wire, down into your cathode, right? Adding electrons is reduction. And then you have your two solutions, and then your salt bridge where your cations and anions can go back and forth and complete the circuit. Your electrolytic cell is all in one container, like I said. The electrons flow through the wire, but it's because the battery is forcing them to do that. So it forces the electrons down here into your cathode. Remember, they still go anode to cathode. And then because this is an electrolyte solution, right? Remember, it's made of ions. That's what an electrolyte conducts electricity. Your electrons are able to go through here, up to here, and then back around. So that is kind of basics of what an electrolytic cell is and compared to a voltaic cell, similarities and differences.